In this video, you will learn about solving rational equations. A rational equation, also known as a fractional equation, is going to have fractions in it. So just to get started, let's practice finding the least common denominator, or the LCD, for each of the following expressions. Remember that when you're finding a least common denominator, we want to take each factor, that's part of a multiplication, the most number of times it appears in a single fraction. So for this first example, we have two factors, 3 and -4, and so our least common denominator here is 3 and -4, or -12. In the next example, we have a factor of x minus 2 in the first denominator and x plus 3 in the denominator. So our LCD in this case is also going to be x minus 2 and plus 3. In the next example, we have several factors. We have 2, we have x plus 1, we have 3, we have x minus 3, and this is just a repeat of the x plus 1. So when I find my least common denominator, 2 appears only once. X plus 1 appears in the first fraction once and in the third fraction twice, so we're going to take it twice. We also need the factor of 3, and then x minus 3 only appears once. So this is our least common denominator there. Okay, so when we're solving a rational equation, we have to watch out for extraneous solutions. These are solutions that we might get when we're solving, but when we check it, it turns out it makes one of the denominators equal to 0. So one thing we're going to do is always make sure that we identify our extraneous solutions. So we're going to start. These are the steps. Identify the values of x that make the function undefined. In other words, where is the denominator equal to 0? Determine the least common denominator. Then we will multiply all terms in the equation by the least common denominator, and this will allow us to clear the fractions. And then we're going to solve for the variable. In these cases, that will be x. And then at the very last, we have to check and make sure that our possible solutions are not some of the extraneous solutions that we identified in number 1. So let's take a look at our first example. One thing I like to do when I'm working with fractions is go ahead and make everything a fraction. So I'm going to put this 4 over 1. And I'm going to look for my least common denominator. So we have a factor of 3, a factor of 2, and a factor of 1. So our least common denominator is 3 times 2, or 6. So now I'm going to multiply everything by 6, like this. Actually, let me do it this way. 6 here, 6 here, and 6 here. Now when I do that, you'll notice 3 goes into 6 twice. So we'll have 2 times x minus 8. 2 goes into 6 3 times. So we'll have plus 3 times x minus 3. And then 6 times 4 is 24. So what we've been able to do by multiplying by the least common denominator is eliminate all of our fractions. And then we just solve as we normally do for a linear equation. So 3x minus 9 equals 24. 2x and 3x is 5x. Minus 16 minus 9 is minus 25. And we get x equals, if I add 25, 5x equals 49, and then x equals 49 fifths. There were no x's in our denominators, so there were no extraneous solutions here. So our answer here is the 49/5. So we're going to do that again over here. First thing I'm going to do is write 15 as a 3 times 5. That's going to help me find my least common denominator. So I notice that I have 3 once in the first fraction, once in the second fraction, so I'll get a 3 in my LCD. I also have a 5, appears once in the second fraction only, and an x. So in this case, our least common denominator is 15x. So when I multiply by 15x, and I'm going to do that for each one of these, I notice that 3 goes into 15 5 times, and we have 5x. That 15 will cancel with that 15, and we'll get minus 8x. And over here, the x's will cancel, and we'll get equals 15. We should note that x cannot equal 0, because if it did, it would cause this denominator to be 0. So this is an excluded value. All right, so 5x minus 8x is minus 3x equals 15. Dividing by minus 3, we get x equals negative 5, which is not an excluded value, so our solution is x equals minus 5. So let's look at a couple more examples. When we look at these denominators here, we notice that our least common denominator is x minus 3, and our excluded values are going to be x equal to 3, because if I put 3 into that denominator, I'll get a 0. So the way we've been doing this, I can multiply both sides of this equation by x minus 3. And what happens when I do that is all of my denominators go away, and I get x squared equals 9. Taking the square root of each side and making sure that we remember to take the positive and the negative, we get x equals 3 and x equals negative 3. But we know x equals 3 is an excluded value, so our solution is just x equals negative 3. Now I just want to call your attention to the fact that this is called a proportion. When we have two fractions equal to one another, like a over b equals c over d, we can cross multiply. And what that does is give us AD equals CB. So had I done that here, I would have landed with x squared times x minus 3 equals 9 times x minus 3, and then we could divide both sides by x minus 3. So it's just another way to solve this equation because it is a proportion. All right, let's take a look at D. D says x plus 6 over x equals 5. And as I said before, as long as I have fractions, I may as well make them all fractions. I'm going to put these over 1. I notice that my least common denominator is just x, and my excluded value is x cannot equal 0. So if I multiply everything by x, then I will get x squared. Here the x's will cancel, so I get plus 6 equals 5x. And this is a quadratic, so I am going to move the 5x over so that I have it equal to 0, which is very typical with a quadratic. And if I'm lucky, this will factor. So two numbers that multiply to positive 6, that add to 5. So I think that's -2 and -3. And then the zero product rule, we set each of these factors equal to 0, and we get 2 and 3. And neither of these were our excluded values, so we actually get two answers here, x equals 2 and x equals 3. For our last example, we have one that... Okay, so in order to find my least common denominator, I need to make sure that all of my denominators are factored. So I'm going to rewrite this as 6 times y plus 3 plus 2 over y, and then I'm going to factor my y squared minus 9, which is a difference of two squares, as y plus 3 and y minus 3. I now need to identify my least common denominator and my excluded values. So my least common denominator is each factor the most number of times it appears. So I notice that I have a y plus 3 once in the first fraction and once in the last fraction. So I have a y plus 3. I have a y once in the second fraction. And then I've already taken care of my y plus 3, but I do have also a y minus 3. So for our excluded values, anything that would make any one of those denominators 0, we get y cannot be -3, y cannot be 0, and y cannot be 3. So when I'm done solving, I'm going to check and make sure that my solutions are not any of my excluded values. So I'm going to multiply everything by my least common denominator. That's going to look like this: y plus 3, y minus 3, and y plus 3, y minus 3, and y, and then I'll squeeze it in here, y plus 3, y minus 3, and y. I like to write it next to each one because then I can see what I'm canceling. So in this case, the y plus 3's are going to cancel. In this case, the y's are going to cancel. And in the last case, the y plus 3 and the y minus 3 are both going to cancel, leaving that y. So now we have the first fraction, 6y times y minus 3 plus 2, and I'm going to go ahead and multiply these because I know that that's y squared minus 9, and then y times 5y minus 3. So let's now solve this. I have 6y squared minus 18y plus 2y squared minus 18 equals 5y squared minus 3y. So let's collect like terms on this side. So we have 8y squared minus 18y minus 18 equals the other side. And then I notice that I have a quadratic, so I am going to subtract the 5y squared and add the 3y. And I'll get 3y squared minus 15y minus 18 equals 0. So now I have a quadratic. I notice that each one of these coefficients is divisible by 3. So I am going to divide the whole equation by 3. That will make my numbers smaller. Y squared minus 5y minus 6 equals 0. And this does factor. multiplies to negative 6. Negative 6 and positive 1 will work here. And then setting each factor equal to 0, we get y equals 6 and y equals negative 1. And neither of these were our excluded values, which were 0, 3, and minus 3. That concludes this video of rational equations.